Hey guys, so we are thinking here about the order of operations. Emphasis on the order that you do operations, right? So a little bit of vocabulary, and you have this sheet. So what you can do is with a marker or a highlighter or a pencil even, you can underline or kind of note. You can even add extra notes in the space as you see fit that might just help you in understanding how this works. So a numerical expression is different than an equation. So in an equation, right, you hear the word equal kind of inside, meaning whatever's on one side of the equal sign has to be balanced with the other side of the equal sign. And an expression, there isn't an equal sign, right? Instead, it's sort of this mathematical phrase that can have any sorts of numbers and any sorts of operations. So it can be whole numbers, it can be not whole numbers, it can be positive, negative, and it can have any sorts of operations like adding, subtracting, multiplying, dividing. When you raise numbers to exponents, to a power, right, using exponents, the raising numbers to whole number powers or exponents are considered numerical expressions as well, because all an exponent is repeated multiplication, right? So 2 to the third power, like you see here, is the same as 2 times itself 3 times. The exponent amount of times 2 times 2 is 4, 4 times 2 is 8. The value of a numerical expression is found by simply sort of solving or simplifying the expression itself. So it's just the answer. It's not an equation, right? So there's not like a this equals this. It's just sort of the most simplified version of an expression. So if you look at this example here, you can see that this numerical expression can be simplified down to the most simplified form of itself, which is 25. So how do you do that? So if we solve this expression here as an example, we're going to use a certain order of operations. So you may have already have the song sort of stuck in your head or not, but it goes like this. Grouping symbols, grouping symbols. So we look for any sorts of parentheses or brackets. And do we have any? Well, yeah, we do. We have some here. So we're going to solve what's inside there first. So 4 minus 2 is 2. So I'm going to cross out this 4 minus 2, and now I'm just going to call it 2. I'm going to drop down everything else that I haven't used, and then I'm going to continue. Exponents, exponents. Do we have any exponents? We don't. So we're going to move on. Multiply, divide. Okay, multiply, divide, MD. Left to right. So do we have any multiplication or division? We do. So we're going to do 16 divided by 2. We're going to call that 8. And then we're going to drop down everything we haven't used. Now, if there was more than just the one bit of division, if there was also multiplication or there were more than one, maybe there were two division little problems inside this expression, you look left to right. You do the one furthest left and then the one furthest right. And then we add, subtract, left to right. So we go, is there any addition or subtraction? Well, yeah, there is. 4 plus 8 is 12. So the following expression can be simplified down to its most simplified version of itself to be 12 using the order of operations.